Good morning, everyone. So last meeting we have discussed about the introduction to set theory. So we have discussed the set, the elements of set, and then the set operations. We also discussed about finite and countable sets, and also the product of sets. So today we are going to discuss the answers to the exercises of the chapter 1. Let's start with the problem on sets, elements, and subjects. So let's start with the problem 1.1. Let set A equals x such that 3x equals 6. The question is, does A equals 2? Okay, the answer is of course no, because A here is a set containing the element 2, and A is not equal to 2. Instead, A equals the set containing one element, which is 2. Okay, so 1.2. Which of these sets are equal? We have here RST, TSR, SRT, and TRS. So if you notice, ang nag-iiba lang dito yung order of the elements. So the answer for this, all are equal. Order of elements does not change a set. Problem 1.3. Determine whether or not each set is the null set. So yun lang, no? Aalamin natin kung null set ba ang mga ito or hindi. Let's start with number 1. Set x equals x such that x squared equals 9 and 2x equals 4. So, may dalawang equation na given dito. So, kung nakikita nyo, for the first equation, x squared equals 9, x here must be negative or positive 3. And sa kabila, 2x equals 4, ang x dito must be 2. So, kung nakikita nyo, magkaiba yung value. So, ibig sabihin, walang value yung x na mag-satisfy sa dalawang equation. So, therefore, this set is empty set. For number 2, we have the set y equals x such that x is not equal to x. So, take note, in some other books, yung empty set is defined as the set containing x such that x is not equal to x. So, obviously, this set is an empty set. For number 3, z equals x such that x plus 8 equals 0. So, if you look at the given equation, x plus 8 equals 0 equals 8, merong value yung x para masatisfy yung equation, and that is 0. 0 plus 8 equals 8. So, therefore, yung set na to ay may element na 0. So, this is z equals the set containing 0 as an element. So, therefore, this is not an empty set. For problem 1.4, okay, we have to prove that A equals the set containing elements 2, 3, 4, and 5 is not a subset of B equals X such that X is even. So, madali lang naman patunayan. No? Maghanap lang tayo ng elements ng A na hindi elements ng B. So, if you notice, 3 is element of A, but 3 is not even. Hence, 3 is not element of B. So, therefore, we can conclude that A is not a subset of B. For problem 1.5, so set B equals the set containing D, W equals CD, X equals ABC, Y equals AB, and Z equals ABD. Determine whether each statement is true or false. So, number 1 here, Y is a subset of X. So, tinanong muna natin yung Y. Y, meron siyang element na A and B. And then yung X, meron siyang element na andito, A, B, C. So, obviously, yung AB na nasa Y ay nandun din sa AB. So, therefore, itong number 1 natin, Y is a subset of X, is true. For number 2, W is not equal to Z. So, tinaman na natin yung elements nila, no? W here, ang elements niya ay C and D. And then yung Z, ang kanyang elements ay A, B, and D. So, obviously, magkaiba. So, this number 2 is also true. Kasi talagang hindi sila equal. For number 3, we have here, V is a subset of Z. So, pabaliktad lang, no? But this is also a subset. Ang set B natin, meron siyang element na D. And then yung Z, meron siyang element na A, B, D. So, obviously, yung D ay nandun din sa Z. So, therefore, V is a subset of Z. And this is true. For number 4, we have V is a subset of set X. So, tinanong natin, ang V natin ay meron siyang element na D, and then yung X natin ay A, B, and C. So, obviously, yung element D is not found in the set X. So, therefore, set B is not a subset of X. So, this is false. D is in V, but D is not in X. So, it means it is not a subset. For number 5, set X equals set W. So, tingnan natin kung pareho yung kanilang elements. Dahil kung hindi, false yun. So, ang ating X, meron siyang element na A, B, and C. And then yung ating W ay meron siyang elements na C and D. So, obviously, magkaiba, no? Number 5 is false. For the last one, we have W is a subset of Y. So W here, meron siyang element na C and D, and then Y is A and B. So hindi natin makikita yung elements C, D dun sa Y. So therefore, this is false because W is not a subset of Y. Problem 1.6, prove if A is a subset of the empty set, then A equals empty set. So, i-prove lang natin to, no, na A is equal to the empty set. So, in our class, gusto ko lang yung simple na proving. Hindi natin kailangan yung very formal like we have two columns like first column is statement and the second column is reason. So, hindi na natin kailangan ay ganon. Here, we can prove in a very, very simple way. So, just do this, no, for the proof. Okay, let's start with a subset of empty set that is given in the statement. And we can also say that empty set is a subset of A. That is actually the definition for the empty set. That is, empty set is a subset of any set. So therefore, A and the empty set is subset of each other. So therefore, we can say that A equals empty set also. That is the definition of equal sets. For problem 1.7, we have here prove the theorem 1.1 III or 3. So we have here, if A is a subset of B and B is a subset of C, then A is also a subset of C. So parang ano lang, no? Transitivity. So let's prove that. So again, simple lang din yung gusto ko na proving. So we can start this way. Let X is an element of A. And then from the given, A is a subset of B. This implies that X is also an element of B. And then from that, X is element of B, and from the given B is a subset of C, it means we can also say that X is also an element of C. So in this case, we can now conclude that A is also a subset of C. So parang pinakita lang natin na yung X is nandun siya sa A, B, and C. So we can also say that A is a subset of C, I mean. Okay, for problem 1.8, which of the following sets are finite? Finite means nabibilang natin or countable. We can one here, the months of the year, so very clear. Bilang na bilang natin yan that there are 12 months of the year. So that is finite. For number 2, we have here 1, 2, 3, 99, 100. So it means this is just a counting number from 1 to 100. So very obvious, it is finite. Number 3, the number of people living on the earth. Although, mahirap bilangin talaga, but actually, nabibilang siya, no? Kaya meron tayong tinatawag na world population. So, number 3 is also a finite. Number 4, the set Q of rational numbers. Napakadaming rational numbers. And this is infinite. And then last, the set R of real numbers. Obviously, ito talaga ay uncountable, and infinite. Kasi nga yung definition ng ating countable ay as long as we can, although it is infinite, ay pwede nating gawan siya ng pattern. Pag may makikita tayong pattern, meron siyang pattern, ibig sabihin we can count that, although infinite. Problem 1.9, consider the following sets of figures in the Euclidean plane. So we have here set A equals x such that x is quadrilateral. Set B equals x such that x is a rectangle. Set C equals x such that x is a rhombus. And set D is x such that x is a square. So determine which sets are proper subjects of any of the others. So if you try to remember, no, lahat na ito, no, yung rectangle, yung rhombus, square, are all quadrilateral. So ibig sabihin, itong C is a subject of A, itong B is also subject of A, and D is also a subject of A. And ito naman si square, we can see that a square is also, based on the definition, also a rectangle. At the same time, rhombus din siya. And of course, quadrilateral. So itong si square, set D is a subject of B. It is also a subject of C, and it is also a subject of A. Okay, yun yung three subjects, no? D is a subject of B, D is also subject of C, and D is a subject of A. Actually, proper subject siya dahil marami tayo, halimbawa rectangle, maraming rectangle na hindi naman square. Ganoon din rhombus. May mga ibang rhombus na hindi square. So as quadrilateral. So marami pang ibang quadrilateral na hindi square. So we can say that this square is a proper subject of the three. We can also see, tulad is also a subject of A. Proper subject din, kasi nga hindi lahat ng quadrilateral ay rectangle. And also see that the rhombus is a subset of a quadrilateral. Then we can also say that it is a proper subset dahil nga maraming quadrilateral na hindi lang rhombus. Okay, so let's go to problem 1.10. Determine which of the following sets are equal. So we have here three sets. First here, this one. This is the empty set. Yung pangalawa, the set containing element 0. And then pangatlo, the set containing another set which is a null set. So obviously, hindi pare-pareho yung tatlo na yan. So none of these are equal. Each is different from the other. Next set of problems, which is about the set operations. So let's start with problem 1.11. So let the set U equals 1, 2, 3, 4, 5, 6, 7, 8, 9. A equals 1, 2, 3, 4, and B equals 2, 4, 6, 8, and C is equal to the set containing the elements 3, 4, 5, and 6. So we have to find the number 1, the complement of A. Let's start with the set U. So set containing the elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's try to answer question number 1 here, which is the complement of A. So the complement of A, nakikita natin na yung A natin dito is meron siyang 1, 2, 3, 4. So ang wala dito na nandun sa universal set ay 5, 6, 7, 8, and 9. So that's why that is our complement of A. And for number 2, we have here the A intersection C that is equal to the set containing 3 and 4. So if you try to look at A, 1, 2, 3, and 4, and B, we have here 2, 4, 6, and 8. So ang makikita nating elements na nandito sa dalawa ay only 3 and 4. So that is our A intersection B. And for the third one, the complement of A intersection C. So dahil nakita na natin sa number 2 na ang intersection ng A and C ay set with elements 3 and 4. So ibig sabihin, lahat ng wala dyan na nandun sa universal set, yun yung complement ng A intersection C. So dahil 3, 4 lang yung nandito sa A intersection C, so ibig sabihin, the complement of A intersection C is a set containing the elements 1, 2, 5, 6, 7, 8, and 9. And for the number 4, A union B. So pagsamahin lang natin yung elements ng A and B. So we have here A is yung elements ng A, 1, 2, 3, and 4. At ang elements ng B, 2, 4, 6, and 8. So pag pinagsama natin yan, siyempre hindi pwedeng ulitin yung parehong elements lang. No? Here, the A union B equals the set containing the elements 1, 2, 3, 4, 6, and 8. And for the next question, we have B minus C. That is 2 and 8. Why? So B, where's the set B? The set B containing 2, 4, 6, and 8. And then yung C, 3, 4, 5, and 6. So, ibawas lang natin yung C, no? So, lahat ng makikita natin sa C, tanggalin natin doon sa B. So, maiiwan na lang sa B ay 2 and 8. Okay, that's it. Next problem, we have 1.12. Let U equals the set containing the elements A, B, C, D, and E. And then ang ating A, may elements na A, B, and D. And then yung B, may elements na B, D, and E. So, find. Okay, number 1, A union B. Pagsamahin lang natin yung A union B. So, we have here, A, B, D yung A, B, D, E yung B. So, we have here the union A, B, D, and E. So, lista lang natin lahat ng union ng elements ng A and B without repeating the same element. Number 2, find the intersection of B and A or B intersection A. So, simple lang, no? Ano yung elements na makikita natin sa B, makikita din natin sa A. So, we have here A, B, D, and B, B, D, E. So, B and D nandun sa dalawa. Kaya, yan yung kanilang intersection. The set containing the element B and D. For number 3, what is the complement of B or B complement? So, tingnan natin yung B, that's BDE. And then, let's try to look at the universal. Ano yung nandito sa universal set na wala doon sa B. So, we have here only A and E. C, I mean. So, the complement of B equals the set containing A and C. For number 4, we have here B minus A. So, ganun lang din, no? Let's look at B, BDE. And then yung A natin is ABD. Bawas natin yung ABD. Of course, mawawala yung B and D dun sa B kasi nasa A siya. So, ang maiwan na lang sa B ay E. So, that is the element of B minus A. And the number 5, we have the intersection of the A complement and B. So, para hindi magulo, kunin muna natin yung element ng A complements. So, we can see that our A here is ABD. Ang nandito sa universal set na wala sa A ay C and E lang. So, yan yung ating A complement. And then yung B, okay, rewrite ko lang dito. BDE para mas madali natin makita, no? So now we will get the intersection of these two sets. Ang nakita natin dito is pareho silang may element na E. So yun. So therefore, that is the answer, no? The set containing the element E is the intersection of the A complement and B. For number 6, we have the union of A and B complement. So, ganoon lang din, no? Isulat muna natin, no, para clear. So, A, set A natin, meron siyang elements na A, B, and D. And then yung B complement, o balikan natin yung B natin sa taas. We have B, D, E. Nasa universal, na wala dun sa B ay A and C. So, that is our B complement. So, getting the union of these two sets, okay, of course, pagsamahin lang natin lahat ng kanilang mga elements. Of course, again, without repeating the same element. So we have here A, B, C, and D. For number 7, we have here the intersection of A complement and B complement. So first, unahin muna natin kunin yung complement. Kunin muna natin yung dalawang complement. So the complement of A, we have yung kanina, no, yung lahat ng elements na makikita natin sa U na wala sa A. So yan ay C and E. And then the complement of B, lahat ng nasa U na wala sa B. So B natin is BDE. So ang wala dyan ay na nasa U ay A and C. So kunin natin yung element ng intersection ng dalawang sets na to. So nakita natin, meron silang both element C. So therefore, the answer is the set containing the element C. Number 8, we have B complement minus C complement. So, mas maganda kung kunin muna natin yung B complement natin. So, B complement is AC. Ito yung elements na nasa U pero wala sa B. And then A complement natin is CE. ito yung elements na makita sa iyo na wala naman sa A. So, subtracting this, AC, bawas natin yung C and E, so mawawala yung C, may iwan na lang is element A. So, that is the answer for the B complement minus A complement equals the set containing the element A. And number 9, we have the complement of the intersection of A and B. So, una-una, kunin mo natin yung intersection ng A and B. Actually, we can find that dito sa problem number 2. So, pareho lang naman yung B intersection A at saka A intersection B. That's BD. Okay? So, now, this element, kunin natin ang complement uli niyan. So, ibig sabihin lahat ng nasa U na wala dito sa B and D. So, syempre, tanggalin lang natin yung B and D. May iwan dito sa U ay ACE. And that is the complement of the intersection of A and B. And for the last one, we have here number 10. Then the complement of A union B. So, nakita natin dito sa ating number 1, no? A union B is equal to A, B, D, and E. Nandito. So, kunin natin ang complement niyan. Of course, yung nasa U, nandito sa U, nawala dun sa A, B, D, E ay of course, nag-iisa lang, no? C. So, therefore, the set containing the element C is the complement of the A union B. Now, let's go to problem 1.13. Okay, this is all about the Venn diagram. No? In the Venn diagram below, actually not below, on the right side, okay, a shade. Okay, let's start shading with number 1. We have here B complement. Okay, this is the shade. Siyempre, shade, tingnan mo natin yung B natin is nandito sa may bilog. Of course, the complement of that, lahat ng nasa labas niya. Okay, so let's shade everything outside B. That is our B complement. For U, for the complement of U intersection B, so una-una, identify natin nasaan yung A union B, of course. Yung A union B, yung dalawang sakop ng bilog na to, no? Bilog ng A at saka B, andyan yung union. So, ang complement of that, of course, yung nasa labas ng bilog na yan o dalawa. So, that is the shade. And for number 3, we have here the B, the complement of B minus A. So, tinaman natin, no? Yung B is nandito, of course. Minusan natin ng A, so ito na lang siya. Ito na lang siya. But the complement of that is yung nasa labas. So, the shade is like this, no? Itong puti dito, kita natin, yan yung, yung B minus A. And the complement of that, of course, yung nasa labas. And then last, we have here the intersection of A complement and B complement. So, yun natin. A complement, of course, yung nasa labas. And then B complement, ganun din nasa labas ng B. So, intersect natin sila. Actually, pareho sila. Lahat ng nasa labas nila, yan yung kanilang intersection kasi pareho sila ng complement. Siyempre, sa complement ng A, kasali yung B. Sa B naman, kasali din yung some part ng A. But the question is, intersection ng dalawa sila. So, yung nasa labas nilang dalawa. So, now let's go to problem 1.14. Okay, let's prove that B minus A equals B intersection A complement. So we can have here a B minus A. This is equal to X such that X is an element of B and X is not an element of A. So next, i-rewrite lang natin dito, no? X is not an element of A. Ibig sabihin, X here is an element of the A complement. So we just rewrite that. So, yun na siya. Now, knowing this, X is element of B and X is element A of complement. Alam natin na itong dalawa na to ay the intersection of B and A complement. So, we can have that this is equal to B intersection A complement. So, as simple as this, we have proven that they are equal. 1.15, prove for any sets A and B, then A intersection B is subset of A and A is a subset of A union B. So, prove natin to. Start with letting X be an element of A intersection B. So kapag yung X ay element ng A intersection B, ibig sabihin niyan, X is element of A and also X is element of B. And in particular, X is element of A, pwede rin natin sabihin na A intersection B is subset of A. Kasi si X ay nandun din sa kay A. Now, we can proceed. Knowing that X is element of A, this implies that X is element of A or X is an element of B. And then this statement of course implies that A, kasi alam natin yung X is nasa A din, and the last line here, we also see that X is also in A or in B. So that's why we can say that X or A is also a subset of A union B. So parang transitivity lang siya. And then finally, we can have A is intersection B is subset of A. And then A is also subset of A union B. Okay, next sets of problems are about product sets. So we have here 1.17. Let M equals the set containing the elements Tom, Mark, and Eric. So mga pangalan ng tao to. And set W equals the set containing Aubrey and Betty. So find the product of M and W. Yung elements ng M ay partner lang natin sa mga elements ng W. Okay? So, this is ordered pair. So, alam natin na every first element dito sa ordered pair is an element of M, yung first in the product, and then yung second dyan is the element of the W. So, we have here Tom, Aubrey, parang partner-partner lang sila, no? Tom, Aubrey, and Tom, Betty. Next is Mark Aubrey and then Mark Betty. And then last, Eric and Aubrey and Eric and Betty. So, i-enumerate lang natin na mga yun na yung kanilang product. The product of set M and set W. Okay, so this is another product. The product of A, B, and C. So, if A is the set containing elements 1, 2, and 3, and then B equals 2 and 4, and C equals 3, 4, 5. Best way to do this is to draw a tree diagram. Starting with the element of A here, 1, 2, and 3. And then sa 1, i-partner natin sa element ng B na 2, 4, 2, 4, 2, 4. And then, doon naman, after that, si partner naman natin yung element ng B kay C. So, may tatlong C. So, that's why, eto, 3, 4, 5, 3, 4, 5, 3, 4, 5. Now, enumerating all of these triples, kasi tatlo sila, sorry, triples. So, yun na yung mga elements ng kanilang product. No? So, starting here, 1, 2, 3, 1, 2, 4, 1, 2, 5, and then 1, 4, 3, 1, 4, 4, 1, 4, 5, and so on. So, enumerating all of this, these are all the elements of their product. Okay, so next problem, 1.19. So let A equals A containing the elements A and B, and B containing elements B and 3, and C containing elements 3 and 4. Fine. Okay. The product of A and then B union C. So getting the product. So A, we have A, nakita natin na may elements na A and B. And then yung B union C. Okay, pagsamahin lang natin yung B and C. So we have 2, 3, and 4. And pwede na natin ngayon i-partner-partner sila, no? Ganun, no? A2, A3, A4, and then B2, B3, B4. And listing all the elements we can have here. Next, of A and B union the product of A and C. So, ganun din, no? Kunin muna natin yung product ng A and B, and then product ng A and C, and then let's get the union of this. Then yun na yung ating final answer. So, A and B, itong kanilang product. So, i-partner-partner lang, no? A2, A3, B2, B3. And then A union C, ito naman yung kanilang product. And then, let's get the union of this for the final answer. So, we can have A2, A3, A4, B2, B3, and B4. The elements of their product. The union of their products. The next, itong sagot natin dito sa number 2 is the same with our answer in number 1 exactly the same. So, ibig sabihin, equal yan sila, no? So, the product of A, okay, actually may ganito to class, kalimutan ko lang, lagyan nyo lang ng, yan, parentheses, because they are in group. So, the product of A and the quantity of B union C is also the union of the two products, A and B and A and C. Problem number 3, the product of A and the intersection of B and C. Okay, let's find this. So we have here, okay, kunin muna natin yung A. We have A and B. And then we can see that the intersection of B and C, 2, 3, 3, 4 is 3. So ayan. So just get the product. That's A3 and B3. So yan na yung kanilang product. Now, for the last one, you have here the intersection of the products of A and B and A and C. So, kanina, kinuha natin yung unions nila. Now, their intersections. So, tingnan natin kung equal din ba. So, now, of course, kunin muna natin yung A times B or the product of A and B. So, ito na yung labas niya. After distributing that A3, ito, A2, and then A3, B2, B3. And then AC, ganun din, no? So, we have A3, A4, B3, and B4. So, ano yung intersection nito? So, common for these two sets are, ito A3, meron sa dalawa, and then B3. So, yun lang yung common sa kanila. Itong number 3 is equal to this number 4. So, therefore, we can also say that these two are equal. So, ibig sabihin yan, pag may ganitong problem, we can simplify the solution using this. No? Parang pwede natin siyang i-ganito. Pareho lang din naman. Problem 1.20. Prove product ng A and then B intersection C is equal to the intersections of the two product A and B and A and C. So again, we will prove this in a simple way. Ay patunayan lang natin na equal silang dalawa. So let's start with this one, A times the intersection of B, C. It means that there's an xy such that x is in A and y is in B intersection C. The next statement, parang i-simplify lang natin to, redistribute natin because if y is in B, it is also in C, di ba? So, yan yung ibig sabihin ng intersection. So, we can rewrite that this way. Okay, x and equals A, yun pa rin. Then, ito, pwede natin gawing y is an element of B and also y is an element of C. So, now, kita natin x and y ay nasa A times B and then, ito. And then, another x and y ay nasa A times C. So, parang i-rearrange natin yan or parang i-distribute. So, we can have this. We can say that the element xy is in A times B. And then, yung element ng xy din is nasa A times C. So, parang dinistribute lang natin yung x sa kanila, dalawa. And then now, from this, we can now conclude that if xy is in A times B and also in A times C, meaning nasa intersection nilang dalawa. No? So, the element xy is in the intersection of A cross B and A cross C. So, yan. Okay, so problem 1.21. Let S equals the set containing the elements A and B and then W. Meron siyang sets, meron siyang elements na 1, 2, 3, 4, 5, and 6. And then V, we have the 3, 5, 7, and 9. So this is the question. So, pwede natin actually apply yung equality na na-prove natin previously that this one, the intersection of these products is also equal to this one. So, kasi para mas madali yata mag-solve ng ganito, no? Okay? We find first the S. Okay, that is A and B. And then intersection ng W at saka V.
Ito natin, so
3 and 5. Mas madali mag-multiply ng ganito, di ba? So, A3, B5, and then B3, B5. Yun na yung ating final answer. Problem 1.22. Prove. Let A is a subset of B and C is a subset of D. Then A cross C is a subset of B cross D. So, proving lang din ito. We will start with letting XY, the ordered pair, is an element of A cross C. So, this means that X is in A and Y is in C. Then from the given, A subset of B and C subset of D. This also means that X is also in B and Y is also in D. So combining this, XY is now in B cross D. We can now say that A cross C is a subset of B cross D. Kasi nga dun sa una nakita natin na yung XY is in A cross C. And then we prove that XY is also in B cross D. So therefore, A cross C is a subset of B cross D. Let us continue with classes of sets. Frequently, the members of a set are sets themselves. So, ibig sabihin nun, matatawag natin na class ang isang set kapag ang mga elements nito ay sets din. For example, each line in a set of lines is a set of points. To help clarify these situations, we usually use the word class or family for such a set. The words subclass and subfamily have meanings analogous to subset. Kung sa regular set, ang tawag natin doon sa mga subset ay subset, for the class, we call them subclass or subfamily. Example, itong number 1 natin dito. Ang set na ito, this one, ang kanyang elements ay mga sets din. So that's why this set is called a class. Dahil ang kanyang elements ay mga sets like set containing 2 and 3, set containing 2, and set containing 5 and 6 as elements. Example number 2, consider any set A. The power set of A is the class of a subset of A. In particular, if A equals the set containing A, B, and C, then the power set is this one. Set containing the set A itself, and the set containing A and B, the set containing A and C, the set containing B and C, the set containing A, the set containing B, the set containing C, and the empty set. So ito yung mga subsets nitong set A. So, ipunin natin lahat ng subsets. They are called power set. And then, itong power set na to, this is considered a class. Dahil lahat ng members ng set niya ay sets din. In general, if A is finite and has n elements, then the power set of A will have 2 to the n elements. Example number 3 natin dito, consider the class or the set A equals the set containing the elements, set containing 2 and 3, set containing 4 and 5, and set containing 6. So the question here, which of the following statements are incorrect and why? Okay, for letter A, we have here the set containing 4 and 5 is a subset of A. So is this true? No, this is not true because the set containing 4 and 5 is an element of A, not a subset of A. Then letter B, the set containing members or elements 4 and 5 is an element of A. The set containing 4 and 5 is an element of A. So letter B is correct. And for letter C, the set containing another set, which is 4 and 5, is a subset of A. And this is true. Why? Because the set containing 4 and 5 here is a set inside this set, is an element. So the set containing that element is a subset of A. So letter C is also true. Example number 4. Find the power set of the set S with an elements 1, 2, and 3. So the power set of this S is the class of all the subsets of S. So these are, if we want to enumerate the subset, so we have the set containing 1, 2, 3, the set containing 1, 2, the set containing 1, 3, the set containing 2, 3, the set containing 1, the set containing 2, the set containing 3. And of course, last is the empty set. Hence, the power set of S is this one. No? So, the set containing the following sets as members. The set S itself, and then the set containing 1, 3, parenthesis na naman. The set containing 2, 3, the set containing 1 and 2, the set containing 1, the set containing 2, the set containing 3, and the set containing empty, or the empty set. So, these are the elements of the power set. So, this is a class. So, now, note that there are 2 to the 3 or 8 subsets of S. Okay, now let's go to the partition of the set. What is this? A partition of a set X is a subdivision of X into non-empty subsets which are disjoint and whose union is X. That is, it is a class of non-empty subsets of X such that each A element of X belongs to a unique subset. The subsets in a partition are called cells. Let's have here examples to clarify the definition. Consider the following classes of subsets of X. So we have here X equals the set containing the elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. The question here, which of the following below is our partitions of X? If we look at letter A, this is not a partition of X. Why? Dahil actually kulang ito, no? So makikita natin na wala ito siyang 7. 7 is an element of X, but we cannot find 7 here. So this is not a partition of X. For the letter B, so tingnan natin, this is also not a partition of X. O, tingnan natin yung 5 dito ay nadoble. So, may 5 dito, may 5 dyan, hindi pwedeng madoble yun. So, dyan pa lang, we can say that this is not a partition of X. The letter C, ito actually yung partition ng X. Why? Nahati ng tama yung elements ng X na hindi siya naulit at lahat is nandito. 1, 3, 5, then 2, 4, 6, 8, and then 7, 9. Example number 2, let X equals the set containing the elements A, B, C, D, E, F, and G. And then let set A sub 1 equals ACE, A sub 2 equals B, A sub 3 equals with elements D and G. And then yung B nandito, tingnan nyo na lang. And we have C here, C1, C sub 2, and then C sub 3. Also, we have D sub 1. So, ito lahat. Now, the question is, which of the following, okay, A1, A sub 1, A sub 2, A sub 3, B sub 1, B sub 2, B sub 3, C sub 1, C sub 2, C sub 3, and then D sub 1 are partitions of X. So, the answer is the C sub 1, C sub 2, C sub 3, and D sub 1. Dahil ito lang sila yung tama, yung pag-partition. Because if we look at letter A, o tingnan natin yung letter A, kulang, no? Walang F dito sa tatlong sets. Walang F. So, hindi siya partitions. Yung B naman, bakit hindi? Doble yung A, E dito. Doble yung element na E. So, therefore, hindi uli ito partitions. For the C, so ito yung tama dahil na-divide ng tama yung partition sa tatlo. Kompleto at saka walang na doble. And then, of course, yung letter D, actually the set is a partition of itself. Example number 3, find all partitions of X, wherein X equals the set containing the elements A, B, C, and D. Each partition of X contains either 1, 2, 3, or 4 distinct sets. For the number 1 here, ito yung one distinct sets. So, yung buong set mismo ng X, A, B, C, D. So, buo siya one distinct set. For number 2, we have here ilan to? 1, 2. So, tigda dalawa. Tigda dalawa yung partitions. Dinivide sa tigda dalawa lang. So, A, then partner niya B, C, D. And B, A, C, D, C, A, B, D. So, there are many, many ways of writing them. Pwede rin siyang tagdalawa, AB, then CD, AC, BD. So, tigda dalawang distinct sets. For number 3, we can also divide a set into 3 distinct sets. So, tulad nito, A, then B, then CD. So, there are many ways also to partitions in 3 different sets. For number 4, we can also partition them with 4 distinct sets. Siyempre, tag-isa-isa, apat lang naman sila. No? So, set containing A, set containing B, set containing C, and set containing D. All in all, there are 15 different partitions of X. Next, the index class of sets. When we speak of an index class of sets, denoted by A sub I, such that I is an element of set I, or simply A sub I. We mean that there is a set A sub I assigned to its element I in set I. The set I is called the indexing set, and the set AI are said to be indexed by I. When the indexing set is the set N of positive integers, the index class A sub 1, A sub 2, A sub 3, and so on is called a sequence of sets. By the union of these sets A sub I, denoted by U sub I in set I of A sub I, or simply U sub I of A sub I, we mean the set of elements it's belonging to at least one of the A sub I's. And by the intersection of the A sub I, denoted by intersection sub I in the set I of A sub I, or simply intersection sub I of A sub I, we mean the set of elements it's belonging to every A sub I. So we have here the symbols for the union and intersections of these sets. To make it clearer, we have here example number 1. Let n be the set of positive integers for each n element of n. Let a sub n equals x such that x is a multiple of n. That is also equal to the set containing the elements n, 2n, 3n, and so on. We have to find letter A, the intersection of A sub 3 and A sub 5. It means A sub 3, the set containing the elements of multiples of 3. And then the set A sub 5 with elements containing multiples of 5. The intersection of both of them actually is just the multiple of 3 and 5, that is multiple of 15. For the letter B, same method. For the intersections of the set sub A, wherein the elements are multiples of 4, and then A sub 6, the elements are multiples of 6. The intersection of these sets is the set containing the elements of multiples of 12. Take note, 12 is a least common multiple of 4 and 6. For letter C, we have here the union of these sets, where P is the set of prime numbers, is this one. Of course, the counting number starting with 2, 3, 4, 5, 6, and so on. Hindi kasali yung 1 dahil nga 1 is not a multiple of any prime number. Now, let's go to the algebra of sets. We have here the definition. A non-empty class A of subsets of U is called an algebra of sets if 1. The complement of any set in A belongs to A, and 2. The union of any finite or countable number of sets in A belongs to A. That is, if A is closed under complements and finite countable unions. Kung ibig sabihin niyan, we have to satisfy these two conditions in order for us to say that a certain class of set is an algebra of set. So we have here example number 1. Let X equals the set containing elements 1, 2, 3, and 4. Then determine whether these two sets, S sub 1 and S sub 2, is an algebra of set on X. We have to satisfy the two given conditions. For letter A, so this is the set sub 1 containing the elements, the set empty, the set containing 1, set containing 2, set containing 1, and 2. Dito pa lang makikita natin na pag kinuha natin yung complement of the empty set, that is actually equal to X. And dun pa lang, kita natin na X is not an element of S sub 1. So therefore, S sub 1 is not an algebra on X. Kasi dapat, ang lahat ng sets na nandito sa S sub 1 ay dapat andyan din ang kanyang complement sa S sub 1. So dyan pa lang, tapos na yung ating test. Hindi na natin kailangan i-continue dun sa union of two sets. Dahil dito pa lang sa number 1 test, nag-failed na. So we can now conclude that S sub 1 is not an algebra on X. So let's try this number 2 or letter B here. So the set sub 2 contains the sets empty, set X, the set containing 1 and 2, and the set containing 3 and 4. So let's try to check if this is an algebra on X. S1, kunin natin yung complement ng bawat elements ng S sub 2. So let's start with the complement of X. That's actually empty. And then yung empty, makikita natin nandyan sa set S sub 1, S sub 2 I mean. And then next, we will get the complement of the set containing 1 and 2. So the complement of that is the set containing 3 and 4. Containing 3 and 4, nandyan pa rin sa S sub 2. Wala tayong problema dun. And then the complement of the one, we have the set containing 3 and 4. The complement of this is of course the set containing 1 and 2. And then this set can also be found in the S sub 2. So walang problema. So lahat ng complements ay nandyan, makikita pa rin sa S sub 2. And for the union of empty set, union X is equal to X. And X nandun pa rin sa S sub 2. Next, we have union of the empty set and the set containing 1 and 2. That is equal to set containing 1 and 2. Nandun pa rin yung 1 and 2 sa S sub 2. Then, empty set union, set containing 3 and 4. The answer is the set containing 3 and 4. Nandun pa rin siya sa S sub 2. And then, next we have to get the union of set containing 1 and 2 and the set containing 3 and 4. The answer is X actually. Then X is nandun din sa S sub 2. And then X union, empty set is X, nandun yun kanina. Then X union, the set containing 1 and 2 is 1 and 2, nandun pa rin. X union with the set containing 3 and 4, nandun din sa taas. Nandun din sa S sub 2. So therefore, lahat ng unions ng dalawang sets ay makikita pa rin dun sa S sub 2. And ganoon din, lahat ng complement ng bawat elements nun ay nandun din. So therefore, we can now say that S sub 2 is an algebra on X. This is the end of the video lesson for chapter 1. See you on the next video for chapter 2. Thank you. In this video, I'd like to present to you and discuss with you the contents of the chapter 2, the techniques of counting. The probability has actually started in these techniques. The fundamental principles of counting, the combinations, the permutations. All of these are sometimes referred to as the combinatorial analysis, the technique wherein we can identify or determine the number of possible outcomes of a certain experiment without actual counting or enumerating the whole thing. So let's try to discuss this one by one. Let us start with the fundamental principle of counting. Saan nga ba ito ginagamit? So this can be used actually in determining the number of ways the procedures can be performed in different order. Example, meron tayong iba't ibang procedures na gagawin sa isang experiment. At saka importante yung order kung ano yung dapat mauuna. So example, N sub 1 yung possible ways of performing the procedures 1. and then n sub 2 for procedure 2, and then n sub 3 for procedure 4, and so on. So if you want to determine the number of ways the different procedures can be performed in this order, we just have to multiply the n sub 1, n sub 2, n sub 3, and so forth. These are actually the different ways each of the procedures can be performed. Or to make this clear, so let us have this example. Suppose a license plate contains two distinct letters followed by three digits with the first digit not zero. How many different license plate can be printed? So yung procedures na gagawin natin dito ay 5. First, we will choose the first letter of the two, and then second, of course, yung pangalawang letra. Third, yung first digit. Fourth, the second digit. And fifth, the last digit of. Alam natin naman na there are 26 letters in the alphabet. So, ibig sabihin, meron tayong 26 ways of choosing the first letter. 26 yon. At pag napili na natin yung first letter, syempre hindi pwedeng ulitin kasi nga two distinct letters. So yung pangalawang letter, meron na lang tayong natitirang 25 letters to be chosen. So there are 25 ways of choosing the second letter. And then next, we will choose the first digit. Hindi siya dapat 0. So ilan ba yung numbers na hindi 0? There are only 9. 1 to 9 yun. And then the second digit, pwede nang 0 doon, pwede nang mag-repeat din yung number. So there are 10 choices. So there are 10 different ways to choose the second. And of course, the third one, ganun din. Kasi pwede namang mauulit yung numbers, no? Hindi siyang repeated. Ang sinabi lang, yung first digit lang yung hindi pwedeng ulitin. Hindi pwedeng 0 pala. So ito na siya. 26 times 25 times 9 times 10 times 10, that is equal to 585,000 plates. Again, ulitin ko. 26. Ito dahil may 26 ways of choosing the first letter. And then next is 25. Dahil yung napili na natin yung first letter, kaya 25 na lang yung naiwan na pagpipilian natin. So, there are 25 ways. 9, dahil ang first digit dito sa 3-digit number must not be 0. Kaya, 1 to 9 lang yung pwede nating pagpipilian. At lahat ng yon ay 9 lahat sila. And then, second digit is 10. 10 different ways to choose the second digit dahil pwede na tayong pumili from 0 to 9. And the third digit, ganun din, 0 to 9. Kaya, i-multiply lang natin lahat ng ito, yung 25 times 26 times 9 times 10 times 10, that is equal to 585,000. Yan ang ating sagot. Let's go to factorial notation. The product of the positive integers from 1 to n is denoted by the special symbol, the n factorial. We have here the formula. N factorial equals, we just multiply the numbers in sequence, starting with 1, 2, 3, 4, up to ano man yung ating value ng n. We also note that 0 factorial equals 1, and then 1 factorial equals 1. So therefore, 0 factorial is equal to 1 factorial. So alam kong familiar na kayo talaga dito. So bigyan ko na lang kayo ng simpleng example. So number 1, 7 factorial is just equal to 1 times 2 times 3 times 4 times 5 times 6 up to 7. And then these 7 factorials can also be written in this way. 7 times 6 factorial. Or we can also write this as 7 times 6 times 5 factorials. All of these are equal. We can use this actually in sometimes in simplifying the factorial notation. Another example we have here is division of 2 factorials. 7 factorial divided by 4 factorials. We can use the shortcut. I mean, we don't have to expand the whole thing. Dun sa 7 factorial, we only write 7 times 6 times 5 times 4 factorial. Kasi 4 factorial yung ating denominator, so we can cancel them out. So, naiwan na lang dito is just 7 times 6 times 5, and that is equal to 210. Itong number 4, ganun din. So, mas mataas yung nasa denominator natin. So, we will expand only the denominator. And the numerator, i-retain lang natin yan kasi maka-cancel din yan. No? 6 factorial divided by, so itong 8 factorial will become 8 times 7 times 6 factorial lang. Para ma-cancel na natin yung 6 factorial para hindi na maghaba yung ating solution. But if you really want, pwede pa rin naman, no? Habaan nyo. Yung 6, gawin yung 6 times 5 times 4 times 3 times 2 times 1 if you want. But mas maganda, as short as possible yung ating solution. The answer here, cancel na yung 6 factorial sa numerator and denominator. So, ano yun na lang is sa denominator na 8 times 7. Kaya 1 over 56 ay yung sagot. Now let's go to permutation. An arrangement of a set of n objects in a given order is called the permutation of the objects, taken all at a time. An arrangement of any r less than or equal to n of these objects in a given order is called an r permutation or a permutation of the n objects taken r at a time. So, meron tayong dalawang uri dito ng pagkuha ng permutation. It is taken all at a time or taken r at a time. And this permutation is denoted by this symbol. Capital P open, then n, comma, r close. Or we can also write this way, N, P, R, and R are subscript. Or we can also write this way, P, and may R sa baba. To give you the formula, we have here the theorem 2.1, the permutation of n objects taken R at a time. The permutation of n taken R, so I think we can read this that way. Permutation of n taken R is just equal to n times n minus 1 times n minus 2 times n minus 3 and so on and so forth. Or in the formula, we can have here the shortcut n factorial all over r factorial times the quantity of n minus r factorial. And for the other one, the permutation of n objects taken all at a time, we have here the corollary 2.2. So there are n factorial permutations of n objects taken all at a time. So hindi natin kailangan gumamit ng formula na sa taas ng permutations. We can only have the n factorial as an answer kapag yung ating permutations of n is taken all at a time. It means that r here is equal to n. We just have to write the permutation of n taken n is just equal to n factorial. We have your example. Number 1, consider the set of letters A, B, C, and D. What is the permutation of these letters taken all at a time? Ito yung example ng taken all at a time. So, ang solution lang dito ay n factorial. Our n here, because there are 4 objects, A, B, C, and D, n equals 4. So 4 factorials is just equal to 4 times 3 times 2 times 1, and that is 24. Example number 2 natin dito ay example ito ng taking r at a time. Find the number of permutations of 6 objects, say A, B, C, D, E, and F. Taken 4 at a time. Ang ating n dito ay 6 and then ang ating r ay 4. Taken 4 at a time. So the solution we can have here that just substitute to the formula. Permutation of 6 taken 4 at a time equals 6 factorial all over 4 factorials times the quantity of 6 minus 4 factorials. So yung sa ating numerator, we can just write that as 6 times 5 times 4 factorial. Hanggang dyan lang tayo. 4 factorial sa baba, we don't have to expand that kasi makakancel silang dalawa dito. Yung denominator dito ay 2 factorial and that is just equal to 2. So, we can cancel this 6 and 2 para shortcut. It can be divided by 2. So, naiwan sa taas ay 3. Kaya 3 times 5 na lang dun sa numerator natin. And that is 15. This time, let's go to the permutations with repetitions. The number of permutations of objects, some of which are alike, as illustrated below in this theorem 2.3. The number of permutations of n objects which n sub 1 are alike, n sub 2 are alike, and up to n sub r are alike. Compute the permutation. N factorial all over n sub 1 times n sub 2 times n sub 3 and so on up to n sub r. For our example, we have here how many different signals, each consisting of 8 plugs, hang in a vertical line, can be formed from a set of 4 indistinguishable red flags, 3 indistinguishable white flags, and a blue flag. Yung 4 dito are alike, 3 are also alike. So we can apply the formula. We can just have 8 factorial all over 4 factorial times 3 factorials times 1 sana ito, but we don't have to write times 1 factorial here kasi pareho lang din naman yun. 4 and 3 here, ito yung alike. 4 indistinguishable red flags, they are alike, kaya 4 yan. Another alike, the 3 indistinguishable white flags, so 3 yan. And a blue flag. So 1 blue flag dapat yan, we can have here 1 factorial here, but we don't have to write that kasi same lang naman. Simplifying this, we can have, so yung ating numerator ay expand natin hanggang sa 4 lang din para ma-cancel yung 4 dito at saka 4 dyan. That is 8 factorial will become 8 times 7 times 6 times 5 times 4 factorial. All over 4 factorial, and then we can expand this 3 factorial to 3 times 2 times 1. To simplify further, nakikita natin dito 3 times 2 here is 6. So we can cancel 6 there. Ang naiwan na lang sa taas, 6 times 7 times 5, that is equal to 280. Next is about ordered samples. What is this? Choosing one object after another from n objects, say r times, that choice is an ordered sample of size r. There are two cases. The first case is the sampling with replacement. Here, the object is replaced before the next object is chosen. Now, since there are n different ways to choose each object, there are, by the fundamental principle of counting, n times n is equal to n raised to the power of r. This is the different ordered samples with replacement of size r. In the other case, sampling without replacement, we can have here, the object is not replaced before the next object is chosen. Thus, there are no repetitions in the ordered sample. In other words, an ordered sample of size r without replacement is simply an r permutation of the objects. Thus, there are, this formula is the result of different ordered samples of size r without replacement from a population of n objects. As clear, we have here example. How many ways can one choose 3 cards in succession from a deck of 52 cards? With replacement, without replacement. We need to choose 3 cards in succession. First card natin, kunin natin and then ibabalik natin. Then kuha tayo ng another one and then ibabalik. So therefore, yung 3 procedures na gagawin natin ay pare-pareho lang ang number of possible outcomes niya. That is, sa first choice natin is 52 cards. The second choice, dahil binalik uli natin yung kinuha natin, 52 pa rin. And then the third choice, ganun din 52. So the solution is just 52 times 52 times 52. That is just 52 cubed, or that is equal to 140,608. Yan yung with replacement. So pare-pareho lang yung number of possible outcomes ng bawat procedure. Sa pangalawa, after choosing one card, hindi natin siya ibabalik dun sa deck. Kaya maiwan na lang para sa pangalawang procedure natin ay 50 na lang. And then, after that procedure, we can have 50 na lang yung naiwan dun sa card. Natin gamitin yung fundamental principle lang dito. Yung first procedure natin is 52 possible ways. Second procedure is 51 possible ways. And the third one is 50. So 52 times 51 times 50, and that is equal to 132,600. So sila nung formula ng ating permutations. Itong without replacement is a permutation formula. Para lang tayong gumamit ng fundamental principle of counting. Yung i-multiply lang natin yung possible outcomes ng bawat procedure. But actually, that is a permutation. This time, let's discuss binomial coefficients and theorem. You can see this symbol NR tapos naka-open and close parentheses is actually the binomial coefficients. Read as NCR or N combination R, where R and N are positive integers with R less than or equal to N. This is defined as n combination R is equal to n times n minus 1 times n minus 2 dot hanggang dun sa n minus R plus 1 all over 1 times 2 times 3 times dot hanggang dun sa R. Okay, so this is called the binomial coefficients. Example, we have here 7 combination 3 is equal to yung numerator natin hanggang 5, no? Hanggang doon lang sa n minus r plus 1. So, ang n minus r natin is 7 minus 3, that's 4, plus 1 ay 5. Kaya hanggang 5 lang siya. 7 times 6 times 5. Huwag na natin ituloy hanggang doon sa 1. And then, ang denominator hanggang doon lang din sa 3. No? 3 ang denominator natin. So, hanggang doon lang sa 3. 1 times 2 times 3. Okay. That is from the definition of the binomial coefficient. And this is actually, you can cancel this. 2 times 3 is 6. So, you can cancel that 6 there. Itong 5, hindi ko kinancel yan ha. Nandiyan pa rin yan. So, 7 times 5 yung natira na lang. So, that the answer is 35. Another example we have here, okay, example pa rin kanina, 7 combination 3. We can rewrite this as this one, no? From the previous 7 times 6 times 5 over 1 times 2 times 3. Kung ituloy-tuloy natin yung numerator natin, we can have 7 times 6 times 5 times 4 factorial all over 1 times 2 times 3 times 4 factorial. Ang concept niyan is parang kinompleto lang natin yung numerator hanggang sa 1 para maging 7 factorial. That is 7 times 6 times 5 times 4 times 3 times 2 times 1. So, 7 factorial. And then, since nag-multiply tayo ng 4 factorial doon, we have to multiply also 4 factorial in the denominator para mabalance yung ating equation. So, it will not affect the value of the numerator and denominator kasi parang nag-multiply lang din tayo ng 1. That is still equal to 35. Bakit natin ginawa yan? Kasi parang dyan ang galing yung formula itong combination. Parang ganito siya kinuha. So, we multiply 4 factorial there in the numerator and 4 factorial in the denominator. If we want to write that in the simple form, so we have here n combination r equals ito n times n minus 1 times n minus 2 times dot times n minus r plus 1. So, ito yung galing dun sa previous nating formula, this one. And yung i-multiply natin na 4 factorial here, ito na siya. N minus r factorial. There's the difference actually of the 7 and 3 there sa una. So, simplifying this, we can have yung sa numerator natin, that is actually our n factorial. And yung denominator natin is r. R itong nandito sa baba kanina, that's r factorial times n minus r factorial. So, parang ganito kinuha yung formula ng combination. Galing siya dun sa theorem na ito for definition ng binomial coefficients. Now, we have here the lemma 2.4. The combination of n taken n minus r is also equal to n taken r. In other words, if a plus b equals n, then we can have n combination A is also equal to n combination B. We have your example. 10 combination 6. This is equal to this one. 10 times 9 times 8 times 7 times 6 hanggang times 5 lang. Dahil ang difference ng 10 is 6 is 4. Kaya hanggang 5 lang tayo dyan. All over, 1 times 2 times 3 times 4 times 5 times 6. Yung dito sa denominator, i-completohin natin hanggang dun sa 6. So, the answer for that is 210. This is actually also equal to 10 combination 4. That is, if combination 4 is equal to 10 times 9 times 8 times 7. Hanggang 7 lang tayo dahil ang difference ng 10 and 4 ay 6. Hanggang 7 lang yung ating expansion dito sa numerator. That is based on the previous definition of binomial coefficient. This is all over. Ang ating denominator, i-expand natin itong 4 dito. So, hanggang 4 talaga. 1 times 2 times 3 times 4. Kita natin na equal silang dalawa because if we go back to this one, itong 6 dito, makakancel natin dyan. And this 5 also, we can cancel that there. So, pag tinanggal natin yung dalawa na yan, so, eto na, pareho lang yung lumabas. So, they're actually equal. Yan yung sinasabi dito sa lemma na to, this one. Okay? So, ang ibig sabihin niyan, this 10 combination 6 and 10 combination 4 is the same. As long as yung nasa baba nila, ito yung value ng R natin is 6. 4 sa kabila, that is equal to 10 if we add. Just like, halimbawa, here, 7 combination 2, this is also equal to 7 combination 5. As long as itong ating R dito, 2 and 5, will equal to the n, which is 7. So, equal yan. Bakit natin ito kailangan? Dahil dun sa binomial expansion, ito magagamit natin to. We don't have to solve everything using this formula kasi pareho lang din naman. May mga sila yung mga equivalents. We have here the theorem 2.5. We call this binomial theorem. The expansion of the binomial a plus b quantity raised to the power of n is equal to the summation of this quantity here. Or this is also equal to this one. And if we are going to use the formula for the binomial coefficients, so yung mga coefficients nila actually is ito na yun. No? Starting with n, combination 0, n, combination 1, n, combination 2, hanggang sa n, combination n. So yung mga coefficients pala nung binomial expansion ay galing dito sa theorem na to, binomial theorem. So we can use the binomial coefficient formula or definition to solve the binomial coefficients of the expansions of this binomial. We have your example, a plus 5 raised to the power of 5. If we can see from the formula, ito yung ating coefficients. First term here is 1. Second term is 5. Ang ating first coefficient is 1, so we don't have to solve that. Second coefficient is n. We don't have to solve also this. But if you really want, that is actually n combination 1. Itong first factorial is n combination 0, and that's actually 1. The same as the last term, 1 din. And that is n, combination n is also 1. And the second to the last term is also n. Yung ating exponent, yun na rin yung ating coefficients dito sa second to the last and second from the first. Makikita natin yan dito sa example na to na pareho lang. No? Yung first term natin dito, same coefficient with the last term. And then the second coefficient is same with the second to the last. And so on. So, pares-pares yan sila. Kaya nga, gagamitin natin dito yung lemma in order for us not to solve anymore the other coefficients. Tulad nito. Isosolve lang talaga natin ay starting with the third coefficient, this one. Kasi yung first and second, no need. First is always equal to 1 ang coefficient. Second is always equal to the n. Kung ano man yung exponent natin, yun yung ating second coefficient. Third, yun na yung gagamitan natin ng combination formula. So this is 5 combination 2. Same as 5 combination 3. Kasi dun sa lemma natin kanina. Because 2 here and 3 will total up to 5. Kaya isolve lang natin yung 5 combination 2. And based on the formula, ito yun siya. 5 times 4. Huwag na natin yung tuloy hanggang 3. Kasi nga 3 is the difference of 5 and 2. So kung ano yung difference natin, 5 minus 2 is 3. Hanggang doon lang tayo. No? Mag plus 1 tayo doon, then stop. So hanggang 4 lang. 5 times 4. All over 1 times 2. So we can cancel this. No, that is not. I mean 4 and 2. Or ganito kaliit na number, we don't have to cancel because we can immediately find the answer. 5 times 4 is 20, divide 2 is 10. And finally, ito na siya. Actually, if you remember the Pascal triangle, ganito yun. Galing talaga doon yung coefficients na to. But of course, we don't have to use always the Pascal triangle, lalo na kung masyado nang malaki yung exponent natin. Kasi kailangan natin magsulat pa from the start. From 1, then 1, 1, and so on. So we have to use the binomial theorem to expand the binomial with the given exponent. We have here the properties of the expansion of the binomial a plus b. First, there are n plus 1 terms. Ano yung ating exponent doon sa expansion? We just add 1 and that is the number of terms of all the expansion. Second, the sum of the exponents of a and b in each term is n. If you look at the exponent of every variable dun sa isang term, dapat ang total nun ay yung n, yung exponent natin na n. Third, exponents of a decrease. term by term from n to 0. The exponents of b increase term by term from 0 to n. So, papaliktad. And then 4, the coefficient of any term is n combination k, where k is the exponent of either a or b. Nagamitan natin ng combination formula yung bawat coefficients ng bawat term. Last, the coefficients of terms equidistant from the ends are equal. So, ito yung sabi ko kanina, both ends are equal, second, and then second to the last are equal, and so on. Now, let's go to the Pascal triangle. Kasi katulad ito ng ating binomial expansion. Yung mga exponents nila, yung mga coefficients nila is coming from the Pascal triangle. Coefficient of the successive powers of a plus b can be arranged in a triangular array of numbers called Pascal triangles as follows. From that, we have here the properties of Pascal triangle. First, the first number and the last number in each row is 1. B, every other number in the array can be obtained by adding the two numbers appearing directly above it. So, dyan nanggaling itong theorem 2.6. Yung number below is just equal to the sum of the numbers above. So, kaya pwede natin gawin in the theorem, n plus 1 combination r is also equal to n combination r minus 1 plus n combination r. Doon nanggaling yan sa Pascal triangle na yung sa baba niya ay equal to the sum of the two numbers above that number. Try this. Another formula. If we let n sub 1, n sub 2, and n sub r be non-negative integers such that n sub 1 plus n sub 2 plus ... up to plus n sub r equals n, then the expression n combination n sub 1, n sub 2, hanggang n sub r that is defined as n factorial all over the product of the factorials of the different n states. Example, we have here 7, combination 3, 2, 2. As long as yung nasa baba natin dito ay pareho total, it will become 7. So, pag pareho yun sila, pag ang total na nasa baba ay equal to n here, yun, pwede natin i-apply itong formula na to. This is equal to the 7 factorial all over. Okay, so just get the factorial of each of these numbers here, 2, 3, and 2. Denominator, ang ating highest factorial dito ay 3. So, we can have 2, 3 also here. Na expansion dun sa ating numerator, 7 times 6 times 5 times 4 times 3. Hanggang dyan lang. So, we can cancel the 3 there and 3 here. Yung 2 factorial here is equal to just 2. And the other one there, also 2. So, we can cancel this para shortcut ang ating solution. 2 times 2 here is 4. And we can cancel the 4 there. So, naiwan na lang is 7 times 6 times 5. And that is equal to 210. We also have the multinomial coefficients. This is in theorem 2.7. Dun sa binomial, hanggang dalawang variable lang tayo doon. In this multinomial, hanggang kahit na ilan. So, let's say, a sub 1, yung ating mga variable, a sub 2, a sub 3, and so on, hanggang sa a sub r. And when this is raised to n, ito na yung kanyang formula, the multinomial coefficients. Actually, this is a general formula for the binomial. Dito nang galing din yung binomial expansion na yon. Nagkataon lang na sa binomial expansion ay exactly 2 lang yung ating variable, kaya nga binomial eh. In this multinomial, so 3 up to, depende kung hanggang saan. So we have your example here. Example for this multinomial is this one. A plus B plus C, quantity raised to the power of 3. So if you look at this, paano ba natin kukunin yung mga coefficients? So you can rearrange this, maraming paraan, but this is what I did. Ilista muna natin lahat ng mga terms with the different variables and exponents. So sigurado, katulad kasi sa binomial expansion, lahat ng first and the last term are a single variable with the highest number of exponent. Halimbawa, cube. So yung both side ay naka-cube, A and B, na highest. So ganun din dito. We have here variables A, B, and C. So, ibig sabihin yan, magkakaroon din tayo dito ng single variable na with highest exponent 3, which is A cube. B cube, and C cube. Iyon ang una muna natin gawin. Kung lilista natin yung mga variables na may pinakamataas na exponent. So we have A cube, B cube, and C cube. And then next, i-decrease natin yung kanilang exponent. So starting with A square. Ano ba dapat ang ipares natin sa A square? Para magkaroon din ng exponent na pag i-total natin, yung exponent ng dalawang variable ay 3 din. So parisan natin siya ng B. And then A square, pwede rin natin parisan ng C. Yun yung possible na pwede natin ipares sa dalawa. And then after that, we proceed to B. This time B cube. So parisan natin ng A. Yung B cube, parisan natin ng C. And then, para sa C cube, ganun din, paparisan natin ng A and then B. And then last, decreasing ang exponent, so A to the 1. So ano yung papares natin sa A to the 1? Para yung total ng exponent ng tatlong variable ay 3. So of course, B and C. Yan lahat ang possible combinations ng lahat ng variables with different exponents. So pag nalista na natin lahat yan, saka natin problemahin yung kanilang mga coefficients. The coefficients of the first three terms here, we have 1, 1, and 1. Bakit 1? So ginamitan natin actually nung formula in the previous theorem or example, this one, C cube. Bakit 1 ang kanyang coefficients? Dahil galing yan dun sa formula. Okay, we have 3. Our n is 3. So, 3 factorial all over. Ang exponent natin dito, at saka nag-iisa lang yung variable, c, and with exponent 3, kaya over 3 factorial lang yan. That's why that is equal to 1. So, lahat ng single variable na may exponent na 3, lahat ng kanilang mga coefficients ay 1. Dito naman sa next natin, we have a square b, a square c, ab square, b square c, ac square, and bc square. Pare-pareho yung kanilang coefficients, which is 3. So, bakit 3? Because if you look at the exponent of each of the variable here in the term, it is a combination of exponent 2 and 1. So, if you use the formula, we can have 3 factorial all over 2 and 1 yung kanilang exponent, kaya 2 factorial times 1 factorial. And that is equal to actually 3. Kaya puro 3 lahat yan ang mga coefficients ng lahat ng may exponent na 2 and 1. And then the last term, bakit 6 yung coefficients nito? So if you look at the exponents, we have A, B, C, may tatlong 1 dyan. If you add that, 3 yan lahat. Apply the formula, that is 3 factorial all over yung mga exponents, 1 factorial times 1 factorial times another 1 factorial. Yung denominator natin ay puro 1 lang naman yan. Ang labas niyan is just 3 factorial. And 3 factorial is just equal to 2 times 3 times 1, and that is 6. Ganun yung techniques. Unahin lahat muna natin yung mga variables, kung yung mga possible combinations, in such a way that bawat term, pag i-total natin ang exponent ay dapat equals n, or yung given exponent is 3. Ganon din ang gawin natin dito sa next example natin dito. We have here the quantity of a plus b plus c plus d raised to 3. Unahin natin lahat muna, lahat na may exponent na 3. So lahat niyan sigurado magkakaroon ng exponent ng 3 with a single variable. So we have a cube, b cube, c cube, and d cube. Next, i-decrease natin ang kanilang exponent and then parisan ng ibang variable. Let's start with a. So from a cube, this time gawin natin a square. Ito siya. Lahat ng possible combinations na pwede natin ipari sa a natin. So this time, pwede natin parisan ng b, ng c, ng d, o tatlo. And then next, to the b square, paparisan naman natin ng a, ay yung c, and d, tatlo din. And then for the c square, ganun din, paparisan natin ng a, b, and d. So tatlo-tatlo din sila. And last, for the d square, ganun din, paparisan natin ng a, ng b, at ng c. So tatlo din. And then last, of course, yung a to the 1. So ano yung ang pwede natin ipares sa a to the 1? Yung may exponent na 1? Of course, Pwede natin parisan ng BC, ng BD, ng CD. And then yung B naman, pwede natin parisan ng CD. CD lang. So, ayan, apat yung may one exponent here. So now, ganoon din yung pagkuha ng kanilang mga coefficients. Dito sa first 4, 1 yung coefficients niyan kasi nga single digit and then exponent is 3. That is 3 factorial over 3 factorial. Dito sa pangalawa, 3 lahat ng coefficients kasi nga lahat ng variables diyan ay combinations ng exponents na 2 and 1. So tulad dun sa taas, ang pagkuha ng kanilang coefficients ay 3 factorial all over 2 factorial times 1 factorial and that is equal to 3. Now we have here 6 dahil may exponent na 1 itong tatlong variables. So from 3, so 3 factorial all over 1 times 1 times 1 factorial sa lahat yun. So 6. Next, let us try this binomial raised to the power of 4. So a plus b plus c raised to the power of 4. Ganon din yung techniques. The highest exponent natin dito is 4. So therefore, lahat ng tatlo na to, a, b, c, ay magkakaroon ng exponent na 4. We will decrease the exponent. So starting with a. So from a to the 4, this time a to the 3. So para mag-total ng 4 yung exponent ng term na to, so paparisan natin yun ng variable like b, pwede rin parisan ng c. And then next, to the b square, parisan mo ng a at saka c. And sa c cube, paparisan mo ng a and b. And then after that, so wala nang possible pares, yung para sa may a cube or b cube or c cube. This time, i-decrease ulit natin ang exponent ng a and b from a to the 4, a to the 3, this time square. So, ang pwede natin ipares dyan ay b square para mag-4 din ang kanilang exponent when you add. Pwede rin c square. And pwede rin dalawang variable na tig-isang exponent. So, bc, 4 pa rin ang total niyan. B square naman, parisan mo ng AC. And then for C square, parisan mo ng AB. Okay, so that's it. Now, pag-solve ng kanyang coefficients ay pareho lang din. So, 4. Tingnan natin to bakit naging 4 ang exponent niya? I mean, coefficients. Dahil dito sa exponent na 3 and 1. So, if you solve that using the formula in the previous, that will become 4 factorial all over. Yung exponent is 3 and 1. So, 3 factorial times 1 factorial. That is equal to 4. Kaya 4 lahat ng coefficients ng mga terms na yan. Dito, bakit 6 ito? Okay. Why 6? Dahil, look at the exponent, 2 and 2. So, ibig sabihin, ang coefficients ay magiging 4 factorial all over 2 factorial times 2 factorial. That is equal to 6. Because it will become 4 times 3 times 2 times 1 all over 2 times 2 sa baba. You can cancel this. Cancel. Okay na iwan. 4 times 3 is 12. Divide 2 is 6. So, ganun yung pagkuha. Okay, same way for this, no? Itong a plus b plus c plus d quantity raised to 3. Ganun din. Ilagay lang lahat ng mga possible variables and combinations and then saka problemahin yung kailang mga coefficients. Okay, so hindi ko na-explain yan dahil pareho lang din naman dun sa taas. And now, for your assignment, okay, you can try to do this. The quantity of a plus b plus c plus d raised to 3. So expand this and write the correct coefficients of every term. This time, we are going to discuss the combinations. Suppose we have a collection of n objects. A combination of these n objects taken R at a time, or an R combination is any subset of R elements. In other words, an R combination is any selection of R of the n objects where order does not count. The number of combinations of n objects taken R at a time will be denoted by C and then open parentheses n comma R close parentheses. And we have here the formula of the combination in the theorem 2.8. The combination of n taken r equals actually the permutation of n taken r divided by the r factorial, and that is equal to n factorial all over r factorial times the quantity of n minus r factorial. If you notice from the previous, yung ating binomial coefficient is the same with this formula. So, ibig sabihin nun, yung combination of n taken r is also equal to the coefficient of n taken r. We have here example. By the way, yung combinations as compared to permutations, mas malaki yung sa permutations kasi ang arrangement doon ay nagmamatter. Dito sa combinations ay hindi. Example, when you arrange the elements A, B, C at gawin mong BCA or CBA, those three will be different arrangement. So, different yung permutations nun. Pero dito sa combinations, isa lang yun. That is the difference. In the permutation, it talks about the arrangement. And here in the combination, hindi kailangan yung arrangement. As long as nandun yung, halimbawa, yung tatlong elements, A, B, C. So, it doesn't matter how they are being arranged. We proceed to the example. How many committees of 3 can be formed from 8 people? Yung ating n dito ay 8 and then ang ating r ay 3. Each committee is essentially a combination of the 8 people taking r or taking 3 at a time. So the combination of 8 taken 3 equals, okay, from the formula, after substituting we have 8 factorial divided by 3 factorial times the quantity of 8 minus 3 factorial. So, tingnan natin yung difference ng 8 minus 3 and that is 5. That is the highest factorial in the denominator. Ibig sabihin yan, hanggang 5 factorial lang yung ating expansion dun sa numerator. So, we can have in the numerator 8 times 7 times 6 times 5 factorial. And then denominator, yung 3 factorial dito, we will expand that to 1 times 2 times 3. And then yung difference na 5 factorials, no need na para makancel yan sila dito. Makancel na yung 5 factorials dito na dalawa sa numerator and in the denominator. And then, simplifying further, pwede natin makancel din itong sa denominator na 2 times 3, that is equal to 6. And then yung 6 sa taas. So we can cancel those. Ang may iwan na lang sa numerator ay 8 times 7. And that is 56. Here in the combination, meron din tayong tinatawag na ordered partitions. Just like dun sa permutations, meron tayong ordered samples. Here, ordered partitions. So parang the same yung concept nilang dalawa. This is a combination of n objects where order is considered. Suppose there are 7 objects, example, numbered 1 through 7. We compute the number of ways we can draw first 2 objects, then 3 objects, and lastly 2 objects. In other words, we want to compute the number of ordered partitions. Say for example, A sub 1, A sub 2, and then A sub 3 of the set of 7 objects into these 3 cells. For A sub 1, containing 2 objects, A sub 2 containing 3 objects, and A sub 3 containing 2 objects. So we will do these procedures in order. Mauuna yung 7 combination 2. And then after drawing the 2, ang may iwan na lang dun sa 7 ay 5. Okay, susunod, 5 combination 3 because we need to take or choose 3. And then after choosing 3, may iwan na lang dun sa 5 ay 2. And finally, we will choose 2 out of 2. Kaya 2 combination 2. So we just multiply the combinations of these 3 different procedures. We just multiply 7 combination 2 times 5 combination 3 times 2 combination 2. Simplifying this, 3 combinations, we have 7 combination 2 is 7 factorial over 2 factorial times 5 factorial. And then 5 combination 3 is 5 factorial all over 3 factorial times 2 factorial. And lastly, 2 combination 2 is just 2 factorial all over 2 factorial times 0 factorial. 0 dahil yan yung difference nila, no? 2 minus 2 is 0. It follows the formula of the combination. So if you can see, we can cancel this 5 here, 5 factorials, and then sa denominator na 5 din dito. Also, yung 2 factorial dito, maka-cancel dahil may 2 factorial din dito sa previous na denominator. Kaya may iwan is 7 factorial all over 2 factorial times 3 factorial times 2 factorial, and that is equal to 220. So kung napansin nyo, itong kanyang formula ay parang formula dun sa previous natin na lesson, multinomial na coefficients, yung formula nito. This time, let's go to the tree diagrams. A tree diagram is a device used to enumerate all the possible outcomes of a sequence of experiments where each experiment can occur in a finite number of ways. So dito sa tree diagrams, kailangan natin i-enumerate lahat ng possible outcomes. While dun sa mga previous natin na ginawa, we only determine the number of possible outcomes but not enumerating. Here, we're going to enumerate. So this is the best way to enumerate the possible outcomes through the construction of the tree diagrams. To show that construction, let us have this example. Find the product of set A cross B cross C, where A equals the set containing A1 and 2, B equals the set containing A, B, and C equals the set containing 3 and 4. So here is the construction of the tree diagram. From the elements of set A, we have to distribute this to B and then to C. Parang i-partner-partner natin yan. So let's start with the elements of A, which are 1 and 2. And then each of these elements will be partnered to the elements of B. Nandito siya. Nandito. And then from the B, every element of this B will be again partnered to the elements of C, which is this one, 3, 4, 3, 4. Now, these are all the possible outcomes, starting with this 1, then A, and then 3. So, nandun na yung list niya. And then 1, A, and 4, nandun na. We can have here 1, B, and 3. Nandun na siya. We can have also 1, B, and 4. Nandun na siya. And so on. If we list everything, all the elements, ito na yon. So, ilan to lahat? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, there are 12 possible outcomes of this experiment listed here in this last column here. We have here another example. Mark and Eric are to play a tennis tournament. The first person to win 2 games in a row, or who wins the total of 3 games, wins the tournament. So, dalawa yung conditions. If one player will win in a row twice, tapos ang game. Or a total of 3, tapos ang game. The tree diagram below shows the possible outcomes who win the game. Example, first game. Tapos nanalo si Mark. And then, nagkakaroon tayo ng second game here. At nanalo uli si Mark. Halimbawa doon. So, ibig sabihin, in that point, tapos ang game. Pero pag si Eric ang nanalo dito sa second game, so tuloy ang game. Kakaroon ng third game andito. Halimbawa, sa part ni Mark. And then, in the third game, halimbawa, si Eric ang nanalo dito. So, tapos ang game kasi nakadalawa na si Eric ng panalo. But kung si Mark yung mananalo, continue uli yung game. So, we have another game here. Pag nanalo si Mark dito, tapos na yung game dyan, kaya end point. Pag si Eric ang nanalo, so tuloy pa rin ang game. And there will be last game here. Kung sino man yung mananalo sa kanila, tapos na yung game dyan dahil nakatatlo na sila. No? Each of them will have 3 wins na pagdating dito. Kaya tapos ang game. Ganon din sa kay Eric na side dito. So, same explanation. So, now, if you want to list all of the possible outcomes, umpisa tayo dito. First possible outcomes ito, MM. Second possible outcomes is ito. MEMM. Nandun. And then third, MEMEM. And then MEMEE. And then MEE. So, ilista lang natin lahat yan. Kung ilan yung endpoints natin na nakikita dito, yun din ang dami ng possible outcomes. So, the complete list of this can be found here below. For the complete solutions to Chapter 2 exercises, please visit your Google Classroom. Nandun lahat uploaded. Thank you.